What you're about to see is a new capability we've built. We call it Ephemeral Sandbox Tool Execution. The idea is simple. Every single command an agent runs executes inside its own isolated sandbox. And within that micro sandbox, we enforce a command-specific policy chain using secure kernel primitives. That policy works across multiple layers. It controls which files a command can touch. It controls what other tools that command is allowed to spawn further down its execution chain. It governs which environment variables it can see, and it stipulates what those values should be. It decides which command line flags are permitted and which are denied, and it guarantees that the agent and its tools only ever see a phantom token, a stand-in secret. The real credential is never exposed. Then comes the second layer. Here we apply policy to the network traffic itself with full layer 7 filtering on every HTTP request by both path and by method. Let's step over to the terminal to see this in action. We're going to base this demo on the GitHub CLI tool, a tool that is often reached for by coding agents. Let's look at the configuration for the phantom credential. The credential key field shows a key store prefix. In this case, we are using the Apple security keyring. Support also exists for 1Password, Kubernetes Secrets, Bitwarden, with support planned for HashiCorp Vault and the various cloud-based KMS solutions. Let's first of all run the ghauth command directly within the sandbox. You will note that the token returned is not a real GitHub token. This is instead a short-lived phantom token. This demonstrates that the agent can perform its function without accessing a real secret, thereby preventing any form of secret exfiltration. We will now look at layer 7 filtering. Here you can see that we permit API access to just the read-only HTTP GET methods, and we explicitly lock down the available URL paths to just issues. If you look towards the top of the rendered policy block, you will note that this is applied to GH, which is the command line name for the GitHub CLI. Now we will run a command that asks the GitHub API for the title of issue number 1052, and because that's a GET against an allowed path, the proxy forwards and we get our title back. Here's the other half of the same policy, the deny rules. Post to an issue's path is explicitly denied, with the reason baked right into the profile. Agents may read issues, but never create or comment on them. Let's try and get past this. Instead, we go directly to the raw API with a post. We attempt to add a comment. The command is well formed. The token would typically work, but the layer 7 proxy sees a post to the denied path and refuses to forward it. The mutation never reaches GitHub. Nono doesn't only filter HTTP, it also filters the command shape before the tool even runs. The argument allow list permits the high-level read commands ghIssueList and ghIssueView. We again read an issue, but this time we use high-level command line flags instead of going directly to the raw API. The command is both allowed by the argv allow list and also it passes the L7 filter. So it works. We get the title, URL and state back as JSON. Back to the argument gate, these are the denied command shapes, ghIssueCreate and close. We now try to comment through the high-level command chain. Again, it never even reaches the network. The policy stops it up front. Here we have defense in depth. The argument gate and the L7 gate both decline the request. Finally, the question everyone asks, can't the agent just wrap the command in a shell to dodge the policy? Well, let's try. We will use sh-c and then the command line payload within quotes. The shell launches, but sh is denied. When it attempts to call gh, the call itself is a policy-controlled hop through no shim. The same gh policy applies, captures the same command, and it is denied. Let's try to post my private key as a release artifact to a public repo. It's denied. Everything we've just watched, the reads that went through, the mutations that got turned away, wasn't only enforced, it was recorded. Nono keeps an audit trail of every command that runs through the sandbox. Here we can see a cryptographic backlog of every action the agent has performed, the files it touched, the domains it tried to access, the flags it used, and the environment variables present. Up to now, we've been injecting commands directly into Nono, but many of you will be expecting to see this happen within a real live coding agent. So let's use the popular Claude code, running inside the exact same policy, perform the same read and mutation-based actions. Claude attempts to read the issue. It matches the allow rules at both layers, and so it is allowed to pass. The agent gets its data and carries on. And now, the moment that matters. The same agent, same profile, but this time it tries to post a comment. No denies, at the policy boundary, exactly as it did for our hand-typed attempts. The agent can do its job with real tools and real credentials and still has no way to reach past the line we drew for it. So that concludes the demo, but remember, with No being highly customizable, ephemeral tool isolation can be used within thousands of unique workflows, specific to the operational concerns of the user,